Hey guys, I wanted to talk about the intermolecular force activity that you worked on last week. So, the whole idea of intermolecular force is that there's a force between, inter means between, molecules. So, what is the force between molecules? I asked you to compare two different situations, one in which you had a whole bunch of water molecules, oxygen. Your water molecules should have looked like this. It's a covalent molecule, and I know that because it has all nonmetals. And I said to draw 4 of them. So these are my 4 water molecules, H2O. And I also asked you to draw 4 oxygen molecules. Oxygen is O2. It's bonded to itself. So this is one oxygen molecule. This is another oxygen molecule. I know that oxygen is found bonded to itself in nature because it is a Brinkelhoff twinsy. Brinkelhoff is the acronym for remembering which elements naturally bond to themselves. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Brinkelhoff. Not that you can't have oxygen bonded to something else also, but this is pure oxygen. This is what you breathe. Okay. So the force between molecules. You should have, in your activity, labeled that oxygen has a partial negative charge, while the hydrogen side has a partial positive charge. And the reason why you should have labeled the oxygen side as a little bit negative is because it's more electronegative. You can check table S on your periodic table. Oxygen's electronegativity is 3.4 and hydrogen is only 2.2. So oxygen is a lot stronger than hydrogen. So I'm not gonna label all of them, but I'll just label some of them. So there are these polar bonds that each water molecule, like this bond itself between oxygen and hydrogen, is polar. This bond itself between oxygen and hydrogen is polar because of their different strengths. And the whole molecule is also polar because it is not perfectly symmetrical. You can not bend it that way and have a mirror image. So this is a polar, these are all polar molecules. If you forget, remember polar bears are on ice, so water is polar. Okay, so water is polar. Oxygen, on the other hand, is as nonpolar as it gets. The reason why is because there's no difference in strength from one oxygen atom to another. This guy has a strength of 3.4 according to table S. This guy also has a strength of 3.4 according to table S. So they're the same strength. The molecule is also perfectly symmetrical. So this is a nonpolar bond, and the overall molecule is nonpolar. As a result, there are no poles, so there's no reason to write a partial charge on either side because it doesn't have one. So again, to go back to my water example, water here has a partial negative charge because oxygen is pulling the electrons from the bonds with hydrogen in closer. So it has more electron density, or it's feeling the electrons more than hydrogen is, which is why hydrogen is positive here. But because these two guys are pulling with the exact same strength, no one is hogging the electrons any more than another guy is. So there is no negative charge on either of the oxygens. Okay, so what does it mean if you have a polar molecule versus a non-polar molecule? Well, I asked you to label in the activity the intermolecular force by this like dashed line between the negative side of one water molecule and the positive side of the other. This right here is the intermolecular force. It's between two completely separate, entirely individual molecules. These guys are not connected, but they are attracted to each other because this oxygen is like, hey, I'm kind of negative, and this hydrogen is like, hey, I'm kind of positive. And so negative and positive always attract in chemistry. And so they're attracted here. And then let's see. This part of the molecule, I could draw another intermolecular force. Here there's going to be an attraction between the oxygen on this guy and the hydrogen on that guy. Here there's going to be attraction. The closer they are, like it looks like this guy is kind of closest to these two hydrogens, this attraction is going to be greater the closer they are, kind of like a magnet. The closer a magnet is to the refrigerator, it's more likely to get close and stick. So this is quite strong because there are poles between in the molecule that's attracted to poles in another molecule. Oxygen, on the other hand, does not have poles, so there's no reason to draw any connection between any of the molecules. They're so not attracted to each other, they have no reason to try to hang out. This is why you find oxygen as a gas, because they're like, okay, I see you, oxygen, but I'm not that into you. I'm kind of just vibing by myself. And so oxygen is found as a gas, but water you can find a lot of as a liquid outside because there's all this attraction between the positive and negative side of two different molecules. So polar molecules, there's going to be more attraction. Whereas nonpolar molecules, there's no attraction. This is partially why oil and water don't mix, because water over here is like attracted to other water molecules and oil is nonpolar, so it just water doesn't, want to mix with it because it's not attracted to it. Okay.